Alright, now I'm going to be in this video reviewing complex solutions and working with those, and this only seems fitting the fact that in the previous video we were talking about quadratics. And complex solutions come from when we start looking at imaginary numbers and when we talk about our graphs of quadratics that are not crossing our x-axis anywhere. So I'm going to review how to add, subtract, multiply, and divide, and do another simplifying, and then also talk about solving our quadratics. I also want to show you, how do you use a graphing calculator with all of this too, because that can also be your friend. All right, so remembering that with a complex number comes the imaginary number part. And really all it is it's working with this I. So when you take the square root of a real number, square root of 4 is 2, square root of 25 is 5, square root of 24 is 2 square roots of 6, simplified. Well, now when we take the square root of negative 4, that becomes 2i. Square root of negative 25 becomes 5i. Square root of negative 24 becomes 2i square roots of 6. The square root of negative 1 is what always equals I, and therefore I squared is equal to negative 1. Now we can go a little bit further with all of this too. The fact that we know what I is and we know what I squared is. Let's go ahead and just say, what is I to the third if we take a look at that? Well, think about I to the third as I times I times I. Now if I wanted to go ahead and take the square root of negative 1 times the square root of negative 1 times the square root of negative 1, okay, square root of negative 1 times the square root of negative 1, technically right there, negative 1 times 1, negative 1 is positive 1, but here, square root of negative 1 times square root of negative 1, that's actually going to be negative 1. And so I would have negative 1 times the square root of negative 1, which would be negative I. Or another way to think about this is you could think of it as I squared times I. Well, I squared is equal to negative 1, and I is the square root of negative 1. So here, negative 1 times I, so negative I. If I took I to the fourth power, I'd like to think of this as I squared times I squared. I squared is negative 1. I squared and negative 1. Multiply those together and you get positive 1. If you kept doing this and now you did like I to the fifth power, you start to see a little bit of a pattern going on here. I to the fifth, we could do I squared times I squared times I. I squared is negative 1 times the negative 1 times I, and that would be giving us a positive 1i. And then if I did I to the sixth, we could do I squared times I squared times I squared. Negative 1 times negative 1 times negative 1, and so that's going to give us negative 1. You'll start to see a pattern that's occurring here. Negative I, 1, positive I, negative 1. If we now did I to the seventh, we're going to start seeing these four values start repeating themselves. So just a little bit with a pattern of working with I. As far as the complex numbers go, what it is it's a number that has both a real and imaginary part to it. Sometimes you'll see just the imaginary numbers, so like 5i, that's an imaginary number. But if you see something like 2 plus 5i, that's what we call a complex number. Complex numbers are basically helping us solve quadratics, finding some different points. And you can do simple operations with these as well, which we're going to get into now. So as far as operations go, it's just really like treating that I like a variable. If you're going to add, you're going to add the real parts and the complex numbers together. So 3 plus 6 is going to end up giving us 9. 2i plus 5i would end up giving me 7i, and there you have it. Just be careful with the subtraction. Make sure that you are subtracting everything. So you've got to subtract the real part and you have to subtract the imaginary part. 3 minus 6 is going to end up giving us a negative 3. 2i minus 5i would end up giving us a negative 3i. So being careful about that. You can, if that ever seems a trick, you can always distribute and work at it that way, and then work with addition. So 3 plus a negative 6, 2i plus a negative 5i, you could do that too. Multiplication, you're going to do FOIL just like you would with working with a binomials, in fact, FOILing those out. So 9 times 6, so then that's going to give us 54. 9 times 5 is going to give us 45i. 4i times 6 would give us 24i. And 4i times 5i would give us 20i squared. So again, you're just like you're working with a binomial, FOILing it out. Combine like terms, so I've got 54 plus 69i plus 20i squared. And here's where we're going to make one little difference. If this was just a multiplying two binomials together, we'd leave it like that. But we know that there's something about I squared, and we know that I squared is equal to negative 1. So we're going to go ahead here and say, well, this is actually 54 plus 69i minus 20. And so now we can combine the 54 and the 20. So I get 34 plus 69i. Here's just another example to multiply out. First terms, negative 5 times 6 is negative 30. Negative 5 times a negative 5i is a positive 25i. 2i times 6 is a positive 12i. And 2i times a negative 5i is a negative 10i squared. So like terms, I can put my 25i and 12i together, so that's 37i. And then here, negative 10i squared. So once again, that I squared right here is equal to negative 1. Well, negative 10 times negative 1 is a positive 10, so we're going to add 10. Negative 30 plus 10 is a negative 20 plus 37i. And there we just did our multiplication. And then the last one is working with the division as far as the operations go. And this one here, people tend to struggle with and they're not quite sure to do because, you know, they think that there's nothing you have to do with this. Well, our issue is the fact that you have an I in your denominator, and that's what we want to get out of there. So we use this idea of working with the complex conjugate. Now we can use this process also when you're working with radicals like square roots and trying to simplify those. We can use this as well as with factoring to help us do some simplifying. So it can be a really helpful tool as far as working with fractions and trying to get things out of your denominator. So the complex conjugate is the opposite of what we see here. So 3 minus 2i. What I'm going to do is I'm going to multiply both the numerator and the denominator by the complex conjugate. I have to do both because that divided by itself is going to give us 1. And so we're not changing the problem at all. You would need to FOIL this out. So the first terms together, 2 times 3 is going to give us 6. 2 times 2i would give us 4i. 4i times 3 would give us 12i. And 4i times 2i would give us 8i squared. Denominator, 3 times 3 is 9. 3 times 2i is 6i. 2i times 3 is negative 6i, and negative 2i times 2 is a negative 4i squared. Now you might be thinking, well, we still have i's in our denominator, but not actually, we actually don't. Those 6 i's are going to cancel each other out. Now you still have this I squared, but we've talked about how that is equal to negative 1. And so really you have, in your denominator here, you have 9 plus 4. So that's going to end up giving us, sorry, not 15, but 13. As far as the numerator goes, we've got also an I squared right here, so that's equal to negative 1. So that positive 8 is going to turn into a negative 8. Well, if I take 6 plus a negative 8, that's going to give me negative 2. 4i plus 12i would give me 16i. And so using my division here, we get negative, or did I, yep. I think, just one second. I think I have something written down slightly different, so let me just double check here. 2 times 3 is 6, 2 times 2 is 4, 4 times 3 is 12, so hopefully think I did everything. I think we're okay. So yeah, so negative 2 plus or minus 16i over 13. All right, so that's a review working with the operations. Why do we do all this? Well, because when you are getting to your quadratics, there is a chance that you might not have real solutions. And what I'm referring to here is that when you have a quadratic, you have this parabola that can be moved all around your coordinate plane. And right now I see that there are two solutions. My graph is crossing the x-axis at two different places. If I move this graph up, well, now it's only crossing the graph at one place. If I move it further up, notice that it doesn't cross at all. Well, when it doesn't cross your x-axis at all, that is when we are referring to having zero real solutions, and we have two imaginary solutions. And so that is where we go ahead and we look at solving our quadratic. So we do absolutely have to use our quadratic formula here, unless you did the completing the square and you know how to do that. But I'm going to use quadratic formula. So x is equal to negative 1 plus or minus the square root of 1 squared minus 4 times 3 times 2 all over 2 times 3. Let's go to a 6. So negative 1 plus or minus the square root, and here's our problem, because underneath that square root we get a negative 23. Well, we can't take the square root of negative 23, and so we go ahead and we're going to say that my solutions are negative 1 plus or minus I square roots of 23 all over 6. And you have the positive solution of it, you have the negative solution to go along with it. Now, how do you know whether you're going to have complex solutions? How do you know if you're going to have imaginary solutions? Well, you could look at the graph, and we'll be talking a lot about graphing things out and being able to identify those. Also understand that there's another thing that you can do, and that is to take a look at what's called the discriminant. And the discriminant tells you whether the solutions are real or imaginary. And it's part of your quadratic formula. It's that b squared minus 4ac. It's the part that goes underneath your square root. Well, when you're taking square roots, number one, you can't take square roots of negative numbers. So therefore, when this number is less than 0, that's when you have two imaginary solutions. Now, if your value is greater than 0, so say you have the square root of 25, well, square root of 25 is 5. So we could take that 7 plus or minus 5 all over whatever number it is, and you're going to get those two real solutions. Now, if that discriminant is equal to 0, the square root of 0 is 0. So here, if I take 7 plus or minus 0, 7 plus 0 is the same as 7 minus 0. So here we would end up with only one real solution. However, we will talk about how there's only one solution, but it has a multiplicity of 2. And that is going to come later on once we start talking about our polynomial unit. But just kind of looking at, just looking under your square root right there, you have enough information to determine how many and what type of solutions you are going to have. So that video is just a review of complex solutions. Again, if you have any questions, feel free to email me or jot them down so that someone can help you out in class tomorrow.